use the Laplace transform to solve the following initial value problem. So we have a second order linear ODE and two initial values. Okay, so y0 equals 2. This is, by the way, y prime 0 equals 5. So we apply the Laplace transform on this differential equation. So let me write that. Here we have y double prime minus 6y prime plus 5y equals 0. So we apply Laplace. So apply Laplace. That means Laplace of y double prime minus 6 Laplace of y prime plus 5 Laplace of y is equal to Laplace of 0, which is 0. Now we're going to apply the formula Laplace of y second derivative. From the formula list we get that this is just s squared Laplace of y minus s y at 0 minus y prime 0. Okay, Laplace of y double prime is this from the formula, minus 6 times something, so we need to put parentheses because we will be distributing negative 6. Laplace of y prime, again formula, that is s Laplace of y minus y at 0. Okay, that's the Laplace of y prime formula, plus 5 Laplace of y equals 0. Now we apply the initial conditions. We have y0 equals 2, so this y at 0, this is 2, and y prime 0, this is 5, and y0 is 2. Okay, and from these terms, here is Ly, Laplace of y, here is Laplace of y and Laplace of y. So let's factor Laplace of y. Then we get s square here. We need to distribute negative 6, so that makes negative 6s. And there's a plus 5. And we move the remaining terms onto the right hand side. So here is negative s2, 2s, negative 2s, move that over, positive 2s, negative 5, positive 5, and this is negative 2 times negative 6, negative times negative, positive 12, move that over, negative 12. Okay, and if you look at this closely, s squared minus 6s plus 5, this is pretty much the characteristic equation for this linear ODE. Okay, when we were solving, we used to find the characteristic equation. This is a homogeneous case. Then r squared minus 6r plus 5. We have the same thing here. Okay, this is 5 minus 12 is negative 7, and now we divide both sides by this, so that Laplace of y is equal to, this is 2s 5 minus 12 negative 7 over s squared minus 6s plus 5. Okay, that's the Laplace of y. Then how do we get back the original function y? Because solving this equation means we are trying to find y. So take inverse Laplace both sides, then y that comes as a function of t is Laplace inverse of this fraction, 2s minus 7 over s squared minus 6s plus 5. If we look at the formula list, then we have nothing similar to this. Okay, this is a complex fraction, and the good news about this fraction is we can write this as a sum of two simpler fractions called partial fraction decomposition, because the bottom factors s squared minus 6s plus 5, these factors. So let me do over here on the right side, and we take the inverse Laplace. So we have 2s minus 7 over s squared minus 6s plus 5 is equal to, we want to write this fraction as a sum of two simpler fractions, a over and b over. This factors is 5 times 1 5 and 5 plus 1 6. This is pretty much s minus 5 and s minus 1. Okay, and that this implies the top 2s minus 7 equals, because the bottoms will be same, if we combine these two fractions in the right hand side, then a times s minus 1 plus b times s minus 5. For this purpose, this is true for all s. Now when we need to solve for a and b. Okay, so if we take s equals 1, then 1 minus 1 0, then we can find the value of b. So when s equals 1, 2 minus 5 7, negative 5 equals, this is gone, 1 minus 5, that's negative 4b. Now if we divide by negative 4, we get b equals 5 over 4, and take s equals 5, so that b part will be gone. Then 2 times 5 10 minus 7 3 equals 5 minus 1 4a. Okay, this is 5 minus 5 0, this is gone. So or a equals, divide by 4, so 3/4. Okay, so this fraction is in fact a sum of two simpler fractions. So a times 1 over s minus 5, and a is 3/4, so 3/4 times 1 over s minus 5 plus b, that's 5/4 times 1 over s minus 1. So let's write that over here. So this is Laplace inverse of this a over s minus 1, so we can pull a to the front because the 3/4, a is 3/4 times 1 over s minus 5 plus, we can pull b to the front, and b is 5/4, so 5/4 times 1 over s minus 1, 1 over s minus 1. Okay, now let's take the Laplace inverse Laplace transform. So 3/4 stays there, and Laplace inverse of 1 over s minus 5 is e raised to 5t. Okay, if you look at the table, e raised to alpha t, the Laplace of e raised to alpha t is 1 over s minus 5. Okay, similarly this is 5/4 e 1t is t. Okay, this is the solution for the given initial value problem. Okay, final.